Alright, part 2 of the For the Cheap Seats video. Anyway, and so he's done 2 new videos, 35 minutes worth, I guess. Anyway, technical versus non-technical layperson. So he's the one who brought this up, as if this has something to do with the person and not the quality of the argument. So, you know, it's still just bullshit. We see plenty of physicists as his own testimony, not saying it the right way, the correct way, using tacky metaphors and silly analogies and other mush because they don't want to do the hard work of actually explaining it. Feynman even talked about this in his videos. He's posted those videos by Feynman, where Feynman's talking about, well, there's lots of questions, and I have to base it on what information you have and what knowledge you have of the world and things to compare things to. And that doesn't really have anything to do with anything but the quality of the argument. So you're the one using the cheap seat metaphors and defending something that's conceptually vacuous. It's just a fieldy thing, or it's just the geometry tells the mass what to do. I mean, that's just mushy, girly baby talk. You know, that's not a quality argument about function. You know, it's a cop-out. So anyway, you brought it up. People should call you on it because you're the one bringing it up, as if it matters. And in this conversation, especially whether it matters, who's the one who's paying attention to the details, and who's the one who can't seem to follow along? And I'd say the answer is obvious. So in this second one, he says, not exactly like fluid flow. So you're caught with your own testimony. You put witnesses on the stand, and now you're going to say, well, those witnesses didn't mean what they said. You know, you're going to take everything they say, you know. Only pay attention to the part where they said the other guy did it. Don't pay attention to the part where they explained how they're guilty. I mean, you know, it's just more bullshit. You know, and whatever corrections you're going to make, they're going to be already part of the established record, in the sense that no one's arguing it's like the Colorado River, that there's rocks in the bottom and there's eddies and so whatever you're going to say, those qualifications are already an assumption, in the sense the qualifications are part of Suskind's lectures and part of my theory. So those qualifications already exist. Even flow, you know, the tension would be even across the entire field, you know. So just more bullshit. Alright. So that's just for the clarifications. Now, in this video, he brings up the radar experiment. So just one more time, the idea is you have 2-slit experiment, you have single-slit experiment. Now these experiments are completely dependent on Heisenberg and Huygens as part of the explanation for why the effect. In the single slit, it's highly Heisenberg, in the sense that the narrower you make the slit, the more information you're gaining, okay, as a measuring device about the location of the photon. And because of the whole, you know, Heisenberg rule, the photon goes all wacky because it doesn't like you to know where it is. And in the 2-slit, well, and then the single slit, again, it's Huygens creates a convenient second wave that the 2 waves can interfere with each other. So in a single slit, we need 2 waves because we need something to interfere with something, and Huygens conveniently creates the second wave. In the double slit, as I pointed out, they don't even do the math. They don't even bother paying attention to the slit width and the math. But it's the same idea. The mechanism creating the interference is the fact that you have a mechanism that's creating these 2 parallel waves, and they create phase differences at different distances. And the theory is that obviously the interference happens in the processing of the wave, not at the destination. Now, in the radar experiment, there's no slits, there's no Heisenberg or Huygens, to create any complication. There's just a difference in distance from the two transmitters, and that difference creates a difference in the phase. And as Professor Lewin pointed out, he could make the phase of the two transmitters 90 degrees out of phase, and then the dead spot would be dead here in the center. So it's completely, he can modify that with radar, because you're not dependent on the light frequency that we can't modify as easily. So clearly my argument is it has nothing to do with any wave interference. The waves aren't coming out and interfering with each other here in space and then pushing the photons into some new location, or telling them they can't go here to the middle, they have to go over here, someplace else. None of that's happening. The interference is happening at the destination where we can't receive. So the question is does it happen here in the air, or does it happen here when the information is received and the two waves end up being superimposed on each other in time? So the wave is like that, and the two waves are out of phase. So that means the one wave is doing, is creating a hump where the other wave created a valley, which is essentially an on and an on. So this one creates an on here, this one creates an on here, and that ends up destroying this wavelength. So the idea is the two out of phase waves show up, they end up creating a new pattern that is double the frequency of the one being detected. And if your detector is tuned to one frequency, it won't hear what's really happening, which is both the waves arrived and they have a new frequency because of their arrival time being exactly out of phase, 90 degrees. I think it's 90 degrees, but anyway, it doesn't matter. I mean, it's not terribly important. That's a detail. Okay, so that's where we are here. His lack of depth of understanding to understand what's being argued, whether we have interference in the atmosphere or whether we have essentially jamming, destroying the receivability of the signal because its frequency is destroyed. Our ability to detect it with our circuitry. Our circuitry doesn't have enough refinement to be able to see both signals or separate both signals. Now maybe there's circuitry that can. I'm just saying the crap you buy on eBay ain't going to be able to do that. All right.
For probably $10, $15, you can get a microwave leakage detector for a microwave oven. Or
okay, so for $10 he's saying you can get that. Well, I don't think even on eBay you can. Frankly, it's going to be a little more than that. But anyway, let's say this is true, and let's say I could do this microwave experiment. I actually have a couple of broken microwave ovens. I could fiddle around with them. But realistically, as an intelligent person, do I really want to do that? Do I want to mess around on the cheap with microwave emitters? I mean, is that in my personal interest in any way? Okay, so I'm clearly, I know electronics, but I don't, I'm not an expert on microwaves. I can think, oh yeah, foil, different shielding methods, but I really should do that. I really should be playing around with microwaves on the cheap and having limited knowledge in that specialty. That's what a sensible human should do. I don't think so.
mobile phone even to detect it. And
yes, well, I have thought of that. I have a couple of portable phones. I guess they're not mobiles technically, and they're like 6 gigahertz, and clearly they don't have dead spots when you have two phones on. So maybe I could do an experiment with the two phones both open to a receiver, and they have to be connected, making signals to the base, and clearly they're able to do that. But there might be some other way I can do the experiment.
Giving out digits of milliwatts and it occurred to me that if you bought two second-hand microwaves, preferably the same type, same model, or even two new really cheap microwaves, they're pennies now. No more.
No, it would make more sense to use one transmitting circuitry, you know, the high voltage circuitry. So have one circuit and just take one gun off one of the microwaves and have them both run by the same voltage. You can't really use two different admitting circuitries, because then you could have no hope of having them in phase.
And probably in the UK you can get a really cheap one for probably 20 quid. So that's, again, $25 in the US perhaps. So for under $100, I'm suggesting you could set up two
yeah, so I should get two crappy microwaves, okay, and take them apart and play with the microwave guns. Yes. Not really knowing what the fuck I'm doing. I mean, realistically. I mean, knowing enough to get electrocuted and probably to expose myself to a bunch of microwaves. Yeah, that's the smart thing to do.
With holes punctured, just very tiny holes punctured in the grating, which is designed to stop microwaves coming out, just break some of the meshing. And
well, clearly you have to have some way of controlling the admission so there's not an unevenness between the two emitters. You have to have some control mechanism where you have an even amount of microwaves coming out of each one, or the experiment's going to be a little moot.
You would have two sources, independent sources, and you could simulate the recent experiment that has been under contention with literally direct numbers measuring the power, and we could expect to see.
So again, these are all built-in assumptions again, that the microwave detector that's detecting a frequency, that's all it's really doing, it's just detecting a frequency. It somehow is unjammable. Do you know that somehow? So again, your lack of attention to detail here seems to be quite obvious. I mean, as I stated before, the real trick would be to get a very good antenna that's small, you know, maybe folded wires or something, and just take the net voltage on the antenna, because these two things will be very close to the receiver. And even though your antenna is picking a lot of noise from the atmosphere, these two sources should create the primary signal that the antenna receives. 90% of the impacts will be from these guns, and therefore you should easily be able to detect an increase in the voltage in the plane antenna. So I mean, the receiver has to be designed to be able to create to detect both these frequencies. So if the radar comes in these packets, or if it comes in this packet, it needs to be able to detect both of those circumstances to be able to truly function in this experiment. Details are important.
Very directly, the doubling of the amplitude or quadrupling of the power or whatever that was the problem with in Mendel.
No, it's not a problem with me. I'm just saying Professor Lewin said it, okay, and he demonstrated by covering one of the emitters, the signal, okay, diminished by 4 times. It was 1/4 of the signal. So somehow having both signals received was amplifying the audio signal by 4 times. Now, whether that has anything to do with the actual carrier signal is an issue, a question. So you keep ignoring these questions and then talking about how other people are lay people. I mean, it's an important distinction. It's an experiment using a signal on a carrier wave. And it's an important question about how the signal gets amplified and how the carrier wave gets detected. Those are the important variables in the experiment. The most important variables in the experiment.
And, you know, the quartering or whatever it was.
So you think you'd pay attention to whatever it was. See, this is the kind of stuff where you sit here and just wash over the important details and distinctions, the entire point of the argument, and then talk about what lay people are too stupid to follow along. And you're just demonstrating, well, what, you're too stupid to follow along? that these are the important questions and variables. The only way you can detect whether it's happening in the atmosphere or at the source is to answer these questions regarding the detection. Are you detecting? Are you amplifying the audio signal? How is that affecting what is being perceived as your test instrument? Your test instrument says the signal's 4 times stronger. Well, is that an artificial amplification, or is there really 4 times the radar signal? It's an important question.
But most definitely you'll see it go to high or low. That's the current physics.
Yeah, it isn't the current physics. As I pointed out, just as buckyballs aren't photons. And here that you just keep playing this game like it's all the same, and it's all very different. Photons are much smaller than electrons. Electrons create a much different pattern in the sense that they actually do create the pattern that has the nice soft edges. Okay, so where the photons are creating hard bars most of the time, the electron experiment creates the nice smooth waves, right? And buckyballs create barely a pattern. But do you really think buckyballs are obeying the Heisenberg principle and they don't have a location? Do you really think the 52 atoms or whatever it is disappear from any location and just are in some amorphous space? Do you really think that theory can apply to a buckyball? Do you really think it's Huygens-ing its way through the universe? Do you really think that's happening? It's creating little buckyball waves in front of it to figure out where it's going? I mean, you just wash over the fact that each one of these experiments is measuring a different thing in a different material-sized universe. And it's just idiotic to sit there and say, we have a theory that applies to all those situations, and exactly the same thing is happening in all those situations. There's, whatever, wavy wave, and it's all getting in the atmosphere, and it's deciding where things go. My finger is creating wavy waves, and they're deciding where it goes. No, they're not.
So if you're minimum to prove this wrong, that would be an experiment to...
Yeah, I'll figure out my own way to... Look, I think I can prove it wrong with the photons in the double slit experiment by just pointing out how the bars are images. They have nothing to do with any Huygens or probability crap. There's an explicit outcome. Each photon has to go a certain place because each location is represented in each bar. So the photons, it critically matters where the photon is located when it goes into the slit because it has to represent the image. So if I can demonstrate that, then this whole thing is moot because that experiment is proven to be shit. Huygens is shit. Heisenberg is shit. There's no Heisenberg when the photon has to go in a certain location and it has to be represented. That location has to be represented as a general position in each image. I mean, obviously the same photon doesn't go to all 5 images, but from that location there's a probability that it'll end up at that one, that one, that one, that one, that one, or that one. It won't go to Pluto, it won't go to Saturn, it won't do any other bullshit. It's going to make an image in a location.
Try. I'd like to try it myself, but I'm a bit scared at the moment. And as I've suggested in the past, you know, I'll donate $100. Well, don't I'll donate. Somebody donate conditionally that he does this experiment. Any surplus, he can buy himself some fags, can he?
Yeah. So this superfluous crap, like I would take money for an experiment and buy cigarettes with it. When no, I really wouldn't do that. But regardless. You know, unless somebody said, yeah, you know, take some out for yourself. But yeah, I'm going to figure a better experiment. I mean, playing with microwaves just doesn't sound like a great idea. I mean, it's a Snake Plisskenus idea. Okay, I don't think a person who has any kind of risk aversion, any sensible, reasonable standards for how stupid they're going to be, you know, recklessly plays with microwaves.
And cigarettes. The first video, I seem to cover a lot more than that. That was a bit of a diversion. So there's no rubber.
Yeah, it was a bit of a pile of crap is what it was. But whatever. I mean, in the sense that you just demonstrated what you're supposed to say you think you have the right to do, which is say, you people are lay people and you're not getting my high-brained understanding when you're demonstrating the one who's just ignoring a ton of details. Just ignoring them or washing over them with some kind of, but the geometry tells the matter what to do. Isn't that enough of an explanation? Yeah, no, it's really not. It's not even close. Yeah. We have some images changing here, so I better play it. So we had another image of bent space. Did you see that? Another image of dented space. This is another image of dented space. This whatever this is, I suppose these are supposed to be these gravitational waves that he hasn't explained how they can possibly exist, and he won't in this video.
Yeah, these are just all imaginary illustrations. There's no flowing of space-time.
So again, he says there's no flowing of space-time. I can play the Susskind, they're very boring lectures, but clearly it moves that way. It functions that way. And he's backing off from that, but that's what it does. As a fact, it duplicates it. That's why mock gravity works, is because it duplicates the function. And it's a different problem. That's the problem. It's matching gravity is not a problem. Maintaining proper velocity, a sense of inertia over a period of time is where it would break down.
And so
but understand, it only breaks down because of your ignorant understanding and science's ignorant understanding of how velocity works. Because it thinks velocity is magic. It doesn't understand that the velocity comes from the only thing that has velocity in the universe, which is the force. The little bits, the force bits, moving the speed of light. And all other movement is going to be a percentage of that movement.
Evidence is in terms of that equation. That was it. Mendel said, Einstein never said this, he didn't believe in it.
And that's accurate. Einstein had no clue what you're talking about here. He never contemplated these idiotic mechanisms for creating some sort of gravity thing. He knew gravity couldn't stretch over the universe by any other rule than the inverse square law, and that any signal in the gravity, just like our eyes are limited to how we can resolve light from a distance. Car headlights, you can only see them from a certain distance as two lights. From a certain distance, you can't see that they're two headlights. Those are our kinds of rules. Those kinds of rules also apply to anything called a gravity wave. And that you're not going to be able to detect this, two things spinning around each other, from 5 billion light years away. Not going to happen.
It's about Einstein did predict gravitational waves.
Okay, so it's just a lie. He didn't predict them. He didn't do anything. He was asked to opine, and he answered the question. He said, "I don't think so." That's what he said. He said, if there is anything, it's local. It's a charge equation. He answered the question consistent with Maxwell's equations. You can't see this. This from a distance is just a -3, let's say, and a +2 spinning around each other, blah, blah, blah. You can't see it. From a certain distance, it just doesn't matter. All there is a 1. The 3 minus 2.
Well, as it says in this video that I uploaded, and he admits that he didn't think it would ever be detectable. But
no, he didn't. He didn't admit he thinks he didn't do any of that. He said it. He said there's no chance. It's not the same phenomenon. It's not. You can't block gravity with another body. You can't do what light does. Light can create a blink. You can't blink gravity.
It was prior to the discovery of neutron stars and black holes. So
I mean, understand this is just about two things rotating, and that there's two positions they can have. Okay, from our perspective, looking at them. This is the problem Einstein dealt with. Okay, we can see them as two objects like this, or we can see them combined objects. Now, in light, this can create a blink, no light. But in gravity, at minimum, all it can create is half as much gravity in some sense. That this narrow location inside, so this is less than, 5 miles or something by how they're doing this bullshit gravity creation. It's a tiny amount of distance. And from a distance, there's no way we could understand there's not enough difference in the gravity between this and this from a distance. Again, the acceleration towards and the acceleration towards cancel each other out. There's no force being emitted by something because it has acceleration or it's accelerating. Because the thing it's accelerating towards is doing exactly the same thing. There's no huge extra gravity that happens when the two are lined up. And then there's a ton less of gravity when the two are this way. You can't do that with gravity. It's a total mass within a circle. This is what Maxwell's equations do. This is what Gauss's law does. It puts a circle around these things. It puts a circle around these things. And it just doesn't matter what they're doing in here at all. It doesn't matter how they're moving, what they're doing, anything. They can do anything in here. All that's going to be seen is their total, or whatever, a charge of 3. That's it. Nothing else is going to be seen.
In gravity. And indeed, Einstein got that equation in 1915, and in 1916, 1 year later, he had gravitational waves.
He didn't have it. So again, this is just so crap. He had gravitational waves. Where? Show me the document. Show me in 1916 where Einstein said gravity waves are really cool. I'm proposing their existence. Go out there and look for them, fellas, because we're making them right now with the moon going around us. We're waving gravity all over the place. And we're making super strong gravity somehow. No, he didn't say any of that shit.
Another good analogy for gravitational waves is waves on a pond. I don't know about all of you, but I don't float very well. So if I go out in the pond and try to float, I end up kind of thrashing. And you were all, in fact, getting stretched and compressed by the awesome power of my gravitational waves, but you didn't feel it.
Right, you didn't feel it. Now that makes see that's all part of their bullshit, right? Somehow nothing else feels these waves except something 5 billion light years away. The Earth feels it, but nothing else felt it 5 trillion times closer. Yeah, the stuff, the stuff getting billions of times hit by billions of times more force isn't somehow feeling anything. Not even an ouch.
So why is that?
Not even a stubbed toe.
Well, for the answer, we're going to turn to Einstein himself, 1916, who gave us this formula. You don't have to worry about the details, but let me explain what the symbols mean. H on the left is the strain. The strain is the same thing an engineer would talk about the strain on a bar. It's a measure of how much stretching or compressing force. Here we're quoting...
Yeah, and somewhere in here just going to get to the fact that this is a preposterously high, this little number here. 10 to the minus 44 is an insanely tiny number.
The amount of fractional stretching or compressing if the bar didn't have any internal resistance to stretching, if it were really just a free-floating blob of particles, and the gravitational wave washed by, if this h on the left was a tenth, then that free-floating blob of particles would stretch and compress by 1/10 of its length. So that's what h, the strain, is on the left. And on the right, with this I double dot and this d, you have some measure of how hard I'm shaking my fist, and how...
I've tried to explain to DraftScience that the...
and I've countered to the fat pedophile.
Mass, which is said to be the 3 solar suns, is due to acceleration.
So again, this is just nonsense. So he's theorizing that because Einstein says when you're going really close to the speed of light, you get heavier. I've always pointed out how, well, that's wrong anyway. Okay, nothing really that you don't have any evidence of that. And what the real answer can be, quite simply, is that once something's going very fast, there's very little in it to hit with something going very fast. It's hard to add extra speed to it because it doesn't have any mass in the direction, in the circumstance of its direction. So again, I've made this argument. I'll just make it again just for clarity. The idea is I could use school of fish to metaphor. It just doesn't matter. But you have stuff that's moving. You know, theoretically, standing mass would have directionality in all the directions. It would have bits moving in all the directions. And as it moves, as it gains velocity, that means it loses the stuff not going the right way. And so most of its stuff ends up being stuff going the right way. So if it was a school of fish, the faster it goes, it is completely dependent on the fish all going the right way. And if there are still fish saying, I like going left, or I like going right, those fish have to be dragged along. That means some other fish has to take time away from going the right way and correct this fish's wrong direction and say, nope, go this way, like us, you know. And that takes time. And so that's what's slowing the thing down. So if you want to be able to push something that's already going fast, the problem is there aren't too many of these fish going the wrong way anymore. There's not too many fish to correct. So it gets harder and harder to clean out those last few dissenters and make the thing go the speed of light. And that can appear like, oh, it seems like it's heavy because I have to use so much force to push it. But the force is going right through the thing. So again, they don't even understand that conceptually, that most of the force goes through something without hitting anything. But anyway, how else to metaphor this? So he's saying that when they explicitly say that these were two black holes of a specific size going into their end phase, that they're somehow lying. That when they say it's 30 solar masses, they really meant... No, it was only 27 solar masses, and it really gained mass from moving. And so we added 3 solar masses to it when it moved. We increased its mass for you. And then when it crashed, yeah, it gave back those fake masses, went back, were released as gravity waves. It's just crap. Mass is mass. You can't make it up. And the point is that they claim to be converting this mass into something called gravity. And you don't have any explanation for how that process takes place. Nothing in anything Einstein ever suggested suggests you can convert mass into actual gravity. Mass causes the space-time continuum to make gravity. You can't convert it directly into gravity.
It's due to the movement.
And understand, there would be no hope for them without that conversion. If they don't convert matter directly, create a nuclear bomb of sorts, and there's no hope of creating any kind of detectable gravity from 5 billion light years away. There's no way to detect the gravity of something not insanely huge. I mean, you'd have to put the entire universe's mass, all the stuff in the universe, you'd have to put in that location for us to feel any significant gravity from a body 5 billion light years away. There's just no hope that you could receive any gravity, enough energy. And the only way this stupid theory can work is they had to find some way to turn it, we had to find something nuclear they could explode in a millisecond. So not even like a nuclear bomb that releases its energy, you know, it's fast, but nothing like a gravity wave. And it's not releasing very much energy. It's releasing a baseball's, it's not even a baseball, because most of it doesn't nuclearize. It doesn't fission or fuse, most of it. So it's a tiny amount of mass that creates that huge explosion. They're talking about suns worth of mass. So I mean, a nuclear bomb is just, you know, a few grains of dust worth of mass that's actually released as energy. They're talking about a sun in a millisecond.
Speed And we call it acceleration because it's rotational. Yeah, if you can go.
Yes, well, no, the rotational part isn't the accelerating part. So again, that's just a denial of what acceleration, gravitational acceleration is. This especially in a two-body system, especially in a binary system. Okay, clearly it has this direction, and this direction is not the equation. The equation is the pressure of this direction and this direction towards each other. That's the acceleration. That's the direction of the acceleration. So it's just bullshit to say this is about some sort of notion of velocity when this is about acceleration.
Go the same speed, but if you go in a circle at the same speed, it's called acceleration because you're experiencing an extra force continually changing your direction.
Yeah, no. See, so again, it's the acceleration is distinct from your velocity. If you're going in a straight line, that's your velocity. You're going in a straight line. Now, if something changes your direction, that has to be a new force applied. That's the gravitational force. So the Earth wants to go in a straight line in the sense that if you didn't have any gravity, it would go in a straight line. It wouldn't do any orbiting. It requires a force to push the Earth, or for the Earth to absorb momentum in the new direction, and so it's a new force. It's not something it has with its old force. Its velocity is irrelevant this way, to the point that it's acquiring another velocity this way. The two don't really have anything to do with them. There's a complete independence, superposition.
Okay, so whereas in member mics could interchangeably use velocity and acceleration, I do it.
I don't like to interchangeable. I certainly make mistakes sometimes and say velocity when I mean in acceleration, but this notion that I've somehow been unclear about the fact that velocities have to be acquired, and the process of acquiring a velocity is what we call acceleration. So you want to play some game like I don't know that? No, I do know that, and I've made that clear in my videos. And for you to say somehow, no, it's not made clear, no, it's been made really clear. So that's just more lying.
With a nuance and a significance to point out that it's not to do with what we call
what we call, just amazing. He really thinks he's part of some elite group of thinkers, the we's.
Not static mass, not stationary mass. The electron has. Well, we work at the mass of an electron, for example.
Yes, right. He's going to get it right in a minute, but this idea of a vacuum mass too. I mean, vacuum energy. It's just such bullshit. So again, now he's going to compare quantum mechanics to Einstein's relativity. He's going to use the insights we have to how charges and electrons function and sit there and apply it to planets and galaxies. They're not the same. They're made of the same energy, certainly, but they don't function in the same universe. One of them is really close to the fundamental laws, and one of them is really far from the fundamental laws.
And we idealize it as stationary, okay? Because when it's moving about, it's a higher mass, and it's because of the.
So again, he's claiming there's actual mass gain. So again, I would argue that a bullet flying through the air hasn't gained any mass at all. All it's done when it's flying through the air at a 10,000 or 7,000 miles an hour or whatever, all it's done is it's taken something that was evenly distributed, moving in all directions. The energy it had was moving in all directions, and now the energy inside the bullet is mostly going this way, and less of it is going some other way. And that's all that's happened. So the mass, so when it was standing, it had mass in this direction, and mass in this direction, and mass in this direction, and mass in this direction. If you looked at the bullet from any direction, you'd get the same amount of reflections off of it and all the other stuff. Now, the faster you move it, right? If you're looking this way at it, you see it all the time. So if you're looking for 10 seconds, you see a lot of photons bounce back. If you look at 10 seconds this way, oh, the bullet disappeared. So you only get a tiny number of photons back. And that's just a metaphor for this conversion of its mass. But the point is it works as a metaphor. So the mass of the object used to be three-dimensional and even. Now it's becoming more and more one-dimensional, and it's incredibly uneven. So its mass distribution has changed, and now its mass is more pointed in the direction of its movement. But there was no gain in mass. There was a gain in the fact that it has more mass in a direction. For fuck's sake.
Velocity it has. Rest mass. It's called the rest mass of the electron. Okay, so what's happening when you slow an electron down, it's losing mass. But it's the E equals mc squared kind.
Yes, no, it isn't. There's absolutely no E equals mc squared crap in this fake notion that you can magically just create velocities and remove velocities and you don't have to account for where the energy went. That's not E equals mc squared. That's not conservative. That's bullshit.
And mass, it's more energy really. Yeah. So those solar masses is real.
It's really not more energy. Again, as I'm pointing out, it's just the fact that the energy is in one direction. The more directional. When you were standing still, your energy was in all directions. When you're moving a velocity, your energy distribution is now more in just one direction. And the faster you go, the more of one directional it gets. You'll never see a photon going sideways. You'll never see it going, looking at it this way, because it doesn't have any component going this way. It doesn't contain any force going this way. So there's no way to see it. Nothing can reflect off of it. Nothing can do anything, because all its energy is going this way, and you can only see it if it hits you coming at you. That's how it works. It only has mass in one dimension.
Just way of describing how much energy was put into the gravitational field, not.
And again, there is no putting energy into the field. The field will be completely unchanged by Gauss's law, and because all the acceleration, if you're going to claim, okay, these two black holes, these two huge masses are pulling on each other so hard, a tremendous amount of acceleration to push them closer and closer together, to make a tighter and tighter circle. So what we're really talking about is this circle is going to get tighter and tighter. And for it to get tighter and tighter, there has to be tremendous pulls, tremendous amounts of, it would take many, many billions of elephants, pulling all day on the ropes to pull those bodies into each other, to make this circle smaller and smaller. But the point is that all that energy is in exactly the opposite directions. So when this one pulls this one this way, when this object pulls this way, the other object's pulling exactly the opposite way. They're pulling on each other, and therefore there's an outside observer sitting out here feels nothing. There's no effect. Well, like I said, the closer you get, obviously there's an effect, because this distance is longer than this distance is longer than this distance, so there'll be an effect. But I'm just saying, as soon as you go far enough away, this distance and this distance is an undetectably small distance difference. And so it becomes completely irrelevant, and all you have is two masses spinning. And it doesn't matter, they can spin any speed, and the gravity here remains exactly the same. Doesn't matter how fast they spin into each other, it doesn't change the gravity here. And Hythloday's claiming it does, and if he's going to claim it does, then he has to explain how these events happen without clearing the universe all around them. They should blow everything apart. Anything near them, anything within hundreds of light years, should be blown away. should just start, the star should explode because of this vibration they're getting hit with, such a hard vibration. It should just explode. Everything should just fracture. Nothing would be able to survive the impact of a wave strong enough to get to the earth and shake rocks. Nothing.
Mysterious mechanism of rubbing out matter and turning it into waves.
No, that's their argument, okay? It's in their documents, it's in their writing, and it's in their fucking statements. I've played it. I mean, yes, I mean, eventually I want to get through the press conference for the new one because I want to find out how much mass they destroyed in this new one. But it's in their own words. It's just bullshit to say, no, they're really just talking about some theoretical extra mass that the body's never really had. It was just mass from moving. Bullshit. You're not going to make a nuclear bomb out of something's velocity. You can move it as fast as you want. It's not going to create a bomb worth of energy distribution.
Pride about the fact that there's no discussed mechanism for rubbing out matter and turning it into waves. Well, the discussed mechanism is not really a mechanism. It's the consequences, as he has discussed and as I tell, of this equation.
Well, that's just bullshit. It isn't the consequence of that equation. That's not what Einstein said. Einstein never said anything other than obeying simple Maxwell principles here about the fact that you can't make more energy inside of these circles. You can't just, it just doesn't matter what's going on inside. You can't change it. It's a certain amount of mass. It doesn't matter where you move that mass. It's the same mass. It doesn't change.
Einstein developed and saw that there is a mechanism for energy to stress and therefore put energy into the gravitational field.
Yeah, well, again, that's not what he's saying. What he's saying is that there's a relationship between mass and how much friction or how much bite you have in this flow that happens between things. But that tension has nothing to do with creating waves exterior to you, creating energy that is anything other than the energy of the inverse square law created. Matter equals this much. The mass equals the gravity. You can't get around that. And even if Einstein said they do gain 3 solar masses worth of mass from their velocity, Einstein would still argue that you can't detect 3 solar masses from the Earth 5 billion light years away. You could never detect the difference between 3 billion and 3 solar masses and 17 solar masses. There'd be no way to detect it. The gravity is too minuscule. This is an explosion. Again, they're converting the solar masses. They're not detecting the solar masses. They're turning them into gravity. Again, you're so full of shit. To sit there and re-paraphrase and re-manufacture their own argument, pretending that this has something to do with gravity created by bending space or by creating convergences. A regular gravity convergence, even one created by something accelerating, can't possibly create the energy to get to Earth.
How far away you are from my shaking fist. But the elephant in the room here is the number on this slide, 10 to the minus 44. 10 to the minus 44 is a number so small, I don't think it comes up even in physics. I have never heard of a number this small. This number is as if you...
I think Planck's constant is 10 to the minus 33. And I think...
Yeah, well, minus 33 is smaller, okay? Isn't as big as minus 44, so that's not a bigger number.
The cosmological constant is 10 to the minus 120 maybe, so he's slightly...
Yeah, so you're saying this guy who's an expert, okay, in relativity equations doesn't know Planck's constants or the gravitational constant. Oh, okay. Yeah, sure.
Slightly wrong about there not being another physicist, but he made it slightly wrong on that. But he's going to touch on something, trying to give you an idea just how small these numbers are. Right? Now he's going to do it in a way different to what Inmendham normally objects to, and that is the idea that the LIGO interferometer is measuring, capable of measuring a hair of Pluto or something. It can't measure hers.
No, no. No, it says they can measure a hair at Alpha Centauri, not Pluto.
Pluto. That's just an analogy to help you get your idea on the distances involved, the scales. Yeah? That's just an artificial...
Yeah, it's a lie, okay? It's just made up crap. It has nothing to do with measuring anything. And as I pointed out, they could just make it Pluto. They could go to Alpha Centauri. They can go 5 billion light years away. They can go 1 million light years away. They go 1 billion light years away. And it's still the same hair. Because they're talking as if these waves of gravity are made of are titanium. And that any change here is perfectly represented 5 billion light years distant away, and it has just as much somehow force and rock moving capacity. You're just getting a smaller amount, so it can't move as big a rock. But that's not the inverse square law. That's crap.
Thought experiment for you to do to give you an angle visually on the visual story to give you an angle on how small these numbers are.
Took an atomic nucleus, and you lined up atomic nuclei all the way across the visible universe. That would take about 10 to the 44 atomic nuclei. That number, that fractional stretching and compressing, is as if the whole universe changed by an atomic nucleus. That is not a lot of stretching and compressing. And so when Einstein...
Well, it is when you calculate the mass of all of those items, then that's a hell of a lot of stuff moving. So it's a hell of a lot of energy to do that one tiny proton amount of distance. Because you have to move, you have to change lots and lots of fish.
Einstein saw this. He surely thought, well, that was a nice theoretical point I made, but we are never going to see these.
Yes, well, he didn't make, in the first place, he didn't make the theoretical point. So I'd like to see the quote from Einstein where he brought up gravitational waves as some kind of important subject, because he didn't, in my opinion. I mean, what I have read of Einstein on the subject, again, seemed to me to read exactly like he was responding, okay, to somebody else's query. And it wasn't something he gave a shit about. And he just pointed out, there's nothing in this that makes your wave crap possible, because there's no... gravity doesn't create energy. It doesn't convert matter into energy. It doesn't create acceleration into energy. Let's see what else to say. Clearly, by my theory, that can be understood, because there's no way gravity could create something when, in fact, it's shadowing. It's the movement, the acceleration is consuming energy, not producing energy.
Far too small. This is just theoretical physics, never experimental physics. Everything changed.
So again, they just keep saying all this shit is somehow based on Einstein. It's not. This isn't Einstein's invention. It isn't Einstein's baby. It isn't any of this crap, and they just keep sewing this fetus of shit to Einstein's head, because they want to be able to say, they want to give this crappy theory credibility. So they keep forcing Einstein to be glued to it. This stupid, ugly, deformed, creepy piece of nonsense, and they're sewing it to Einstein's fucking head.
When neutron stars and black holes were discovered in the 60s and 70s.
Well, somehow that allows them to change the number to -21. Yeah. Sorry. Bullshit.
If you came last week to hear Professor Rozelle, you learned a lot about neutron stars and black holes. They're unimaginably dense objects. A neutron...
No, so a physicist is saying unimaginably dense objects. Well, we know how dense they are. You can do the math.
A significant bit over. Now, to answer the point that Inmendham cries about this three solar masses being so dangerous and such like, when those black holes were millions or billions of light years away. And
yeah. Well, the point is there's stuff that isn't billions of light years away. There's stuff that's just a light year away, or 5 light years away, or 100,000. Our whole galaxy, let's say, it's 100,000 light years across. that whole galaxy would be extreme. It is like I said, the force is billions of times stronger where those planets are and where those suns are, and they're not going to just get a human hair's worth of impact.